Right now, you can get Disney Plus and Hulu for just $2.99 a month.
I like that.
Your favorites from Disney Plus and Hulu.
Here's what you can expect to pay for your tax prep.
Wait, this is backwards. My last tax guy only ever told me the price after he was finished.
And as a new client, we can match the price.
client winds up having a 4-level neck fusion, and the insurance company's denying it from the beginning. Took him to trial. I won.
Let me welcome everybody. Okay, let me get this. Hello. Okay. Okay. Thank you, everyone, for joining us. And let's see, Pratik has something.
Okay, just making sure it's showing on the screen properly.
Okay.
Yeah. It's just show. Okay, yeah. Never mind. Sorry.
Okay.
Just making
And
sure
then
it
we
was
just
showing
go
properly.
back to that, right?
Yeah.
Okay. Yeah. And then I'm just gonna minimize, or not minimize, slide it down. That this is a control
yeah,
panel or whatever. Yeah. And it's not. Okay. All right. Okay, great. Well, thank you, everybody. Thanks for your patience with us tonight. Everything's new room, new location of Grubhub. And thank you again to John for booking the room, getting the food from Grubhub, and yeah, all these things. And then, you know, it's pretty amazing. But first of all, too, before we get into things, Pratik has extended an invitation to everybody to join. Maybe if you like to have an after, a meetup get together, we can all go to Monk's Pub on Lake Street. Yeah, if you like to join, that's where we're gonna go. And yeah, so it's open to anybody to join. And that's a Monk's Pub. If you are not familiar, that's on Lake Street. And if you go south, just cross back the river to the other side, and it's on Lake Street. So we can all walk there together too. It's like within 5 minutes walking.
Yeah.
So
How many people want to go to that? How many people would like to go get a drink after the meetup? Raise your hand so we can get a table big enough.
we can go.
Okay. So about
Four.
we'll say
Five or
10.
six?
No, I'm just kidding.
Yeah. Okay, you're not joining?
I can't.
Oh, okay. All right. Otherwise, I can give you a ride back. Okay. Anyway, okay. So yeah, let's start this meetup now. So welcome everybody to CJUG, and again with also Kotlin users group, the CJUG together. We're running this meetup, and we welcome Pratik Patel from Atlanta. I'll get to his intro slide deck shortly, but yeah. So you all know already the topic is about Architect's Guide to Managing a Code Base. Okay, let me go, just some housekeeping. But first of all, we're gonna have our usual raffle. And today, we actually only have one license for this today, but we'll be having another raffle, and that will be for a free admission, completely free ticket to No Fluff, Just Stuff, the Great Lakes Software Symposium. Just let me tell you, if you came to the one last time and the person who won the raffle, turns out he won't be able to go. So he has given back his ticket. So now we can raffle it again. So we're giving you all the benefits of this opportunity if you want to enroll in that or sign up for this raffle. So if you're interested, that's the QR code to enter your raffle. And you just need to give your name and also your email address. And then also the bit.ly link too. Now, if you missed this, let me know and I'll share with you the link to this slide deck. So, okay, now just housekeeping. Remember, we have our Chicago Tech Slack, and it's got like 10 or 12,000 subscribers now. Connect with your local tech communities, not just us, but everybody too, within Chicago and beyond. Then we have the Java op heap. If you want to sign up with that, if you're not familiar with that yet, it's run by Freddie Gemay, who was the CJUG president earlier too, like in, I guess, between 2013 and 17, something like that. Okay, and then please join us on meetup.com. Although I have to let you know ahead of time, we're going to switch to a new platform for the meetup.com, and we're working on it to switch to Luma. If you're familiar with Luma, that's actually quite easy, much easier to use and more agile, so to speak, but more modern too. So we'll be switching that, but we'll give you instructions and make sure you follow us there too. And then we have our X, or formerly Twitter account. Please follow us if you haven't already done so. And then we also have our Discord channel. And every time some of you are familiar, we would create a special room for the meetup of the day, of the month. And so this one too, and we invite if Pratik wants to join that, and if any of you have more questions for Pratik or just wants to continue the discussion, you can use this Discord room and the whole Discord server to exchange messages and to continue the conversation. And some community info. So we are a community partner of the following groups and conference organizations, and that's JCon, and they'll be celebrating 10th year of JCon in Cologne, Germany, I should say, and then also Java 30th year. And JetBrains continue to donate to us like 2 free licenses per month for raffling off, and also devitjobs.us if you are looking for jobs.
Did anyone watch the 30th anniversary, Java 30th anniversary live stream today?
No, actually, I didn't get to watch.
Yeah.
Yeah, I think it's recorded, right?
Yeah, you can watch it on demand.
Oh, okay.
So there's some good sessions. There's one by someone you may have heard of called Venkat Subramaniam. You may have heard of that dude. He gave a really good talk on innovations in Java. And there's also a really good talk on Java. I think the title is The Busy Java Developer's Guide to Artificial Intelligence.
Oh.
So it's actually a really good presentation. So,
oh, cool.
Yeah.
Yeah, thank you. Okay, awesome. Thank you. Okay, so just continue on with here some upcoming events. So next week, actually, we'll have another meetup too. And the reason we have 2 days because Pratik just called us up and said, I'm coming. So we said, okay, it's Pratik. So we have a special meetup for Pratik. No, but I'm just kidding. We're good friends with, all jugs. And as you know, Pratik leads the Atlanta Jug and a whole slew of other things he's doing. So anyway, so next week we'll have from Bellsoft is Pasha Finkelstein. Yeah, I think that's how I pronounce his name. I'll verify. So it's already on our meetup.com page, so please sign up for that. He's going to talk about Docker imaging containerization for Spring Boot app. So, and then April 10th, we already booked that with Jerison Baines, and he's right there. he's leading a startup company and Invergence, and the meetup will be at U of Chicago, the Gleacher Center. That will be on April 10th. And then May 13th, we have already gotten confirmation from Temporal. They have this workflow system that they like to be presenting, and it will be hosted at Improving. And then in June, we'll have our lightning talks. So we're inviting all of you, if you're interested, to present a short talk, like 5 to 10 minutes. And we can talk more about it. Maybe we can also do a session on how do you prepare for lightning talks later too, if there are enough interest. So, and then we have other confirmed speakers, including Alina Urenko from GraalVM, and she was supposed to come, but then she doesn't have any travel budget, so she can't come, but she's still planning on coming, and she's based in, well, I was gonna say she's originally from Ukraine, but she's now in Zurich. And then Josie Pamaud from France, he's an Oracle developer advocate, and then also Gerrit Grunwald, also from Azul, he'll be coming in September. So. Oh, yes, and Billy, that's right. Thank you. Okay, I forgot because John talked to Billy at Death Nexus, so, and I wasn't there. But anyway. Oh, yeah, Hussein, later. Sure, yeah, sure. Thank you. And we also are still considering a full length on Meetup too, if you are interested. Okay, oops, and let me see. Okay, just a couple more events too. Java one is next week, so there's this Jug member discount. If you're interested, it's $100 off, and it will be in California next week. So, and then there's also Arc of AI conference by Dr. Venkat Subramaniam. That will be from March 31st to April 3rd in Austin, Texas. So there's a $50 Jug discount. So the promo code is here if you want, or over there. And then raffle, you can get a chance to win a free admission ticket if you like to sign up here with this link that I have up there, arcofai.com/raffle/2. And then to register, you just do the /register. So. And then there's also Great Lakes Software Symposium from No Fluff Just Stuff. That will be May 16th to 17th in Chicago in Itasca. So again, we'll be raffling off one free ticket at the end after the presentation too. And then the discount code is up there, and group discounts available as well. Okay, and if you're interested in speaking at CJUG or would you like to do a lightning talk, it will be in June, and please send email to present@cjug.org. And then for job seekers and recruiters, this is our link on the group on LinkedIn. So we'll invite you to do it. And I forgot to actually ask John if you'd like to say a few words as well. I'm sorry, I'm doing the housekeeping.
Here in November of last year. So I think hopefully you agree that this room is great for meetups. So we hope to be doing a lot more in the future. If you need the restroom, it's right back here. If you go through this door, there's a hallway of lockers. You go through there, and then it's back to the hallway. I think that's about all I need to cover.
Okay.
Anything else? No, yeah, that's it.
That's good. All right, and we.
Yeah, if you need anything else, just come grab me and ask me. Yeah, that's it.
All right, great. Thank you, John. And that's the slide that I have prepared to thank you, John. John is a senior staff engineer, CJUG organizer, and CJUG partner. So, but let me go back to, before I forget, we have Neo4j, just want to remind you, our gold sponsor. And then they are running this monthly raffle too. So if you're interested in entering into a drone raffle, you're welcome to scan this, and then they will be doing their raffle at their head office, and they will notify you if you win too. I think somebody from our group actually won in the past, so they do run that raffle too. So, okay, and then again, John. And then Friends of Sea Jug, these are all our friends, and I'm so glad we have Atlanta Jug, which is Pratik here today, and all the other jugs too.
Yeah, the light sensors.
Yeah.
Okay.
Okay. Okay, so now I think then that's the last slide before we start. Is introducing Pratik. He's a VP of Developer Advocacy at Azul. He leads teams, build products and software, as well as startup companies. And he's a deeply experienced developer. He has titles of lead architect, lead developer advocate, and CTO. And he's author of several books on Java and software development. He's also a Java champion and among a select group of recognized Java technologists. He's an active Java and general tech community leader. You're the president of Atlanta Jug, also leads the JavaScript and web dev meetup groups in Atlanta, and started and organizes the Jug Leader Summit since 2020, and organizer of DevNexus and other conferences. So did I miss anything?
No.
Okay.
Maybe
welcome.
too much, but that's okay.
Welcome, Pratik. We're happy to have you.
Thank you, Mary.
You're welcome.
Mary and I go way back. We used to work together at IBM back in, when was that, 1998?
18 to 21.
Yeah,
It was
18,
like
1998 to 2021.
2021. Like COVID, right? Around,
I know.
yeah.
It was so long ago, right? It was in the before times, as
exactly.
they say. Right? I want to make sure this thing works.
Yeah.
All right. Thank you all for coming out today. Apparently, I hear this is like summer weather for Chicago or something. Is that right? It's like the sun's out, it's not snowing.
Yeah.
So, and we'll get started in just a second. But you know, we have a small enough crowd. I actually prefer to present at smaller crowds because when I present at conferences that have like 2,000 or 3,000 people in the room, number one, it's overwhelming for me because believe it or not, I'm not a natural presenter.
You are.
But it's also, you don't get any interactivity, and so it's just kind of boring, or you're just kind of shouting at people in the audience. So why don't we do this, if you don't mind, if this is okay with you, Mary? Sure. Why doesn't everybody in the room tell us their name, what they do, and which company they work for? Why not? Is that okay?
Sure.
Okay, we'll start with Mary. How's that?
Okay, well, I'm currently, day job, I'm a director of emerging technology for a consulting firm called Calibrity that's based in Cincinnati. That's my day job. And but I essentially do a lot of AI stuff right now, building up the practice. But prior to that, I was advocate and also an engineer too. So for a number of years. So
yeah.
Yep.
My name is Alexander Bundurka. I'm a competency manager with ELEKA. Competency management is some kind of engineering management, but with a strong focus on technology. So basically, Java is my core. Yeah.
Nice.
Thank you.
Hey everyone, this is William. I'm a computer master student. I'm a software engineer. Hey everyone, I'm Shisha. So I'm a senior developer at the city.
Where?
City.
Well, it's great to have students in the house, by the way. So, good.
Okay, I should take a picture.
CRM systems, web scraping, Google dorking, web systems like what we do different so we take answers, data science, and data analytics. So I enjoyed my work.
I think we forgot you up here. Yeah, go ahead.
Developer on digital platform. I work in the US.
At where? Okay, gotcha.
Hello everyone, my name is Aniket. I work for SAP Global and work as a software engineer. I mainly work in mapping, cloud, microservices, big data, based on Power, database, etc.
John?
John Coyne, distinguished engineer of application engineering and developer advocate at Discover Financial Services. Work in our customer technology area to provide systems there, all systems there. Our customers are based at our mobile website and our
Lynn, staff software engineer at
Share some names. I think Mary founder of Emergence, a startup company trying to change the way that software is delivered. I'll be presenting next month. Hopefully, you guys will find that the version platform we're producing is impactful as Spring was when it was released.
Oh, that's bold claim. Okay.
Yeah.
I'm a security company, so developing PKI, pages and stuff.
Okay.
Encryption, signing.
All the stuff I don't want to do. Wonderful. So.
Some pictures.
Say I'm a lead engineer at Allstate Insurance, and I work for one of the internal teams doing rating and some other reporting.
Okay.
Well, I usually do this with you.
Yeah.
Yep.
We used to work for IBM for 24 years, recently left, and I founded my startup called Open Development Platform. I used to have significant studies for IBM, which was our research wing, working with universities and stuff. I still do the same thing, just from a different entity. That's about it. Working on automation platform with agentic framework on top of it. And on top of that, we have product on genomics, on automation of automobiles and telescopes, all kinds of fun stuff.
Okay.
Security here at GitHub, estimation, regular team on PCAs, as well as balances and
Hi, I'm John. I'm a senior staff engineer on the platform team. Yeah.
Okay, do we miss anybody? Oh, right in the back there.
Usually different days, but it would be sometimes Tuesday or Wednesday, but mostly Thursdays. So yeah.
The evenings as well. So I might have to miss y'all until I,
Okay.
graduate, come back later
Okay.
this summer. But just wanted to say hi, and I'm so happy to be here. This is my first.
Great. Welcome.
Yeah, welcome.
Yeah, welcome.
And
Yeah.
you're also very smart for doing a coding boot camp on Java instead of that web JavaScript nonsense.
Yeah,
Just saying.
that's right.
No, I know. It's a lot easier to get a job, especially right now in the Java enterprise space than in the web space. So, and apparently you make a lot more money doing Java than compared to web front end if you look at any of the metrics out there. So you chose wisely. Is all I'm trying to say. So so I always tell young people or older people who are trying to like get into tech, it's like don't just get fixated on doing like JavaScript and Node and web, because the real fun, as everyone in this room will obviously agree with, is doing that hardcore Java server-side stuff, right? That's where the action's at. So anyways, let's get going here. Why is it not on this screen? That's weird. Okay, Mary already gave the introduction, so I'm going to skip all this. The most important thing is on Blue Sky, LinkedIn, and Twitter. I still call it Twitter. My handle is PR Patel, so it's very easy to find me online. If you have any follow-ups, that'd be great. I do work at Azul. I'm not going to talk much about Azul in this presentation, actually, but just a quick shout out since they paid my way to come here. We have an OpenJDK build called Azul Zulu, which is 100% free and will be free forever, that we get 200 million downloads of. So if you're using OpenJDK or any other free build, you have options. You can use Azul Zulu, and again, it's 100% free. We get 200 million downloads of that a year. Lots of people use it, both here in Chicago and all over the world. And then we also have a high-performance JVM, which is proprietary, called Azul Platform Prime, which is very popular among people who need low latency, high throughput, and stuff like that. And towards the end of this presentation, I'll talk about our next generation thing, which is called Intelligent Cloud. Again, I'm only going to touch on it briefly, because the point of me being here is not to pitch these products, but to give you some useful information that hopefully will help you tomorrow when you get to work, okay? So actually, this is code inventory, but I'll talk more about this later. It's like X-ray for your Java apps in production, right? It's a very unique thing. So more about Prime, high performance VM. You drop it in, and you get immediate speed improvements for running any Java workload with no code changes. It's 100% compatible with OpenJDK. And we have some customers that you may have heard of that are running this. For example, there's a company called Apple that makes hardware. You have heard of them? Or another company that you watch like stuff on your TV or your laptop called Netflix. They're one of our customers. And loads of others, a bunch here in Chicago, which I can't remember because we have so many here in Chicago also. But anyways, we're happy to talk to you after the meetup for this. And let's get into the presentation, okay? Can you tell I generated that using AI? I actually did. I actually used Flux to generate it. So because I was like, oh, why should I try to draw something when I can just have AI prompt and get this up? Anyways, so one of the biggest questions that I hear when I talk to folks is, are software architects also programmers, right? And so I have pretty much a background in both. Like everybody else, I started off as a software developer. For many decades, have been doing Java development and done a bunch of other stuff. But for about 7 or 8 years, I was also an architect at AT&T. And as we get through this, you'll see one of the main points here is that the answer to this question really is, it depends, right? It depends on your company and your role and kind of who you are in some regard. So we're going to step through some of that, and then we'll give you some specific tips, things to watch out for, other things in terms of like what you should be thinking about, whether or not you're a software architect, in terms of how do you manage code quality for a code base or multiple code bases. Because this is one of the challenges that architects typically face, is that you're not just zeroed in on one code base, right? Or maybe 2 or 3. You probably do architecture for multiple projects which have multiple code bases. So this can be challenging, but it also presents a big opportunity. And again, a lot of this depends on your organization and what architects do, and we'll cover all that in a few minutes, right? So again, it also depends on your role at that company, and also depends on you in terms of like where your interests are and other things like that, okay? So let's do a quick review of what software architect tasks are. Do I have to just wave my hands? Is that how this works? Okay, you got it? Oh, the sensor's over there? Okay. All right, that's fine. I mean, we can do this in the dark too. It doesn't mind. It doesn't matter to me. So how many people in here are software architects? Just by a show of hands. Okay, so we got a few people who are software architects in here. So for those of you who aren't or aspiring to be or work with them, software architects generally tend to do a few things which are very, very broad, right? They obviously do system design and architecture. A lot of software architects get involved in technology selection. It could be something like that's very big, or it could be something very small, like which library should we use, right? Or which framework should we use, Quarkus or Spring, or like right now probably every software architect in any programming platform is probably asking like, what should we use for building AI type of things, right? So that's one of the big questions now. And what I specifically did when I was at AT&T is I did all 3 of these things, but I focused on the 3rd bullet, which was performance. So I spent basically the last, 4 years of my time at AT&T as a software architect, obsessing about performance and uptime and latency. So that's why when I was talking about Prime and all those things, when I went to Azul, it was a natural fit for me because I spent a long time way deep in the JVM internals, like optimizing systems, Java systems specifically. So anyways, right? So other things that software architects do, setting internal guidelines and best practices, leading collaboration, and I think the biggest one here, and this is a little bit of a soft skill, which is providing leadership and vision, right? So it's one thing to say, okay, we're going to use this library, right? So if I use an AI example, I'll say, okay, we're gonna, instead of using Python, we're gonna do this in Java, and we're gonna do it in LangChain4j, and then people will be like, well, why don't we just use this Python stuff? And then as a software architect, what you have to do is, as you're part of that decision-making process, you have to basically build some ground level support and say to the developers that are on the teams that you work with, or maybe through the organization, right? This is what we're doing. These are the reasons why we're using Java and LangChain4j or whatever library to do it instead of Python, right? It's just an example. I'm not saying you shouldn't look at using Python, but you do a lot of leadership and you provide vision. And this is very critical in a lot of ways, because as a software developer, if I put my software developer hat on, when I think of like development and like, words like vision and things like that, it sounds very mushy and soft. It doesn't sound real. But, if you've been developing for any amount of time, you know that getting a team on board and everyone working in the same direction is extremely important, right? To basically have productivity across your team. Everyone has heard of the myth of the 10x developer, right? But I think the 10x developer is actually real in a lot of ways, because if you work on a team where everyone is working together, you're no longer a 1x developer. You become a 2, 3, 4, 5, 10x developer over time, because the team is working together. You help each other out. You get increased velocity. You write better code and things like that. And we'll talk about writing code and writing better code in just a second. Okay, so that begs the question: how removed should a software architect be from actual coding? Again, the answer, of course, is it depends, right? But depending on the company you're at, the size of your company, and different things that you do, there are some good reasons for architects to be involved with coding, right? And this can, obviously, a software architect has a lot of different things that they have to do. It can be very demanding, mentally demanding job, and doing it well is also very difficult, right? But when I think of software architects, so when I was at AT&T and I was an architect, I did get involved in coding. I did not just code reviews, because code reviews is kind of almost ivory tower sometimes if you're not down in the weeds is not the right word, down in the trenches with other developers, right? So for me, maintaining technical proficiency and credibility was very important to me as a software architect. When I go and talk to developers, especially when I have to make decisions as an architect for what framework we're using or what kind of style of thing we're using. I think Mary mentioned that you're going to have, for example, Temporal coming in soon to do a presentation. Well, Temporal is great actually, but I like to use Restate, which is very similar to Temporal. And if I decide as an architect that my teams are going to use Restate versus Temporal for that kind of long chain transactional type of guaranteed transactional type of operations, I have to be able to understand and justify it, and also possibly initially help people to implement it properly. So again, maintaining technical proficiency and credibility is important in terms of a software architect also doing coding, right? And then of course, understanding implementation challenges and trade-offs. So as an architect, especially when you're doing system designs, you have to understand what's going on all the way down at the code level if you're going to be moving to the cloud. Because then, for example, if you go from being a software developer and you're like a software architect that focuses on cloud, one of the biggest questions that you have up front, you can probably guess where I'm going with this, is how are we going to deploy this stuff? Are we going to use Kubernetes? Are we going to use for something like Fargate, which is a container as a service or CAS solution? Should we go serverless for something like this? So if you don't understand like what people are actually coding or what your teams are actually coding, and you don't understand the low-level things, how can you decide what is the best thing in terms of deployment models, right? Obviously, there's no one deployment model that fits everything, but being able to lead by example. So that's the last thing, is being able to lead by example and earning respect, so that at every corner, you don't have people questioning why you're making these choices. So, software architecture spans all the way from, in my opinion, spans all the way from coding all the way up to just basically meeting with management and filling out TPS reports, okay? That's the not fun part of the job, obviously, but it's everything in between, right? And it depends on where you're at. So on the other side of the coin, we might say, why should a software architect not code, right? And the top bullet is the biggest reason why. You have so much that you need to do. You have time constraints, so you need to be able to focus, have time and energy to focus on high-level concerns. But if you're coding like 25, 50, 60% of the time, do you really have time to do that, right? It's a little bit of a rhetorical question, but it's just something to think about, right? And then, of course, I try not to do this, but as a developer, we have control over our code, so we like to kind of micromanage the things that we work on. It's inherent in what we do as software developers. You manage everything that you do from a coding perspective, software dev perspective, right? I'm going to use this library. I'm going to write my code in this style, et cetera, et cetera. So you have the risk of micromanaging your teams rather than letting people go off, providing guidance and taking a step back and stepping in when you need to. So there's the risk of micromanagement. And then, of course, and this is a big one, is if you're coding frequently, you also sometimes get a risk of having potential bias for implementations and for ways of doing things. It's basically that ivory tower syndrome. You don't feel like you don't need to get input from everybody, which sometimes you don't, right? But you do need to have input from other people so that you're not biased against solutions, especially new things that are coming up, right? So a good example of this is when we moved from essentially raw servers, on-prem types of things to the cloud, right? How, if you think of your own journey from that, how resistant were you to move to the cloud? Did you think that back then we didn't worry about cost because, there was so much money to do anything. But, what are the potential trade-offs for doing that? It sounds risky. We're moving data to the cloud, et cetera, et cetera. But as you know, what happened over time is everyone moved to the cloud. So if you're stuck in that mindset as either systems engineer or a developer, you have a little bit of bias against things like this. So you have to be very careful about this. So if you don't code, then you have a chance to step back and look at the bigger picture and get input from different teams and understand what your business actually needs. Okay, so it's essential for software architects to maintain a strong understanding of coding principles and practices, regardless of whether they code actively. So this is probably the take-home message for these first few slides. John, you don't have to turn it on. You guys okay without the lights on? Okay,
That's
yeah, fine. Don't worry about it.
Yeah.
We didn't have all that warm, like deep dish pizza, so it's not like we're going to go into a food coma with all the tryptophan, right? So, anyways, this is if you get nothing else out of this presentation, I hope it's this. Whether you're an architect already or you're aspiring to be one, it's that you still need to, actually this should be amended a little bit to say strong understanding of modern coding principles, right? So in our universe, code has been around for what, like 70 years now, or the discipline of software development, specifically programming, has been around for a long time. And we don't often, especially nowadays, we don't often get, in my opinion, we don't often get things which really change very much in terms of how you build code, especially at a low level, right? There's all sorts of things out there available, like domain-driven design, right? Everyone's probably heard of that. And then, for years, people have been bashing on about unit testing, right? So these are all good practices. So we don't typically get a lot of things nowadays which are like new and modern coding principles. But from a system design's point of view, it's like you think about just in the last 10 years, the way we deploy things. Instead of doing monoliths, we think about microservices, right? But what's the big thing now, right? If you think about it, does anyone know? Right, so we went from monoliths, and then we went all the way over to this end of the spectrum, well, this far over, to microservices, and then what I call nanoservices are basically serverless cloud functions. That's the ultimate like small function, weave things together that way. But what's happening now? Modular monoliths. So if you've been in this industry long enough, but I know a lot of people in this room have, what's old is new again, right?
Yep.
So now we're swinging back to let's do monoliths instead. Not like the giant stupid like spaghetti ball monoliths, but like we're like, you know what, this microservice thing is great, but we are adding so much overhead by converting and serializing and deserializing the JSON using the network, et cetera, et cetera. It adds a lot of overhead. So, yes. Oh, sorry, I thought you had a question. So anyways, so staying abreast of like what the modern coding practices and things are very important for this kind of stuff, okay? And again, the level of coding involved should be tailored to the specific context of the project and the architect's role. Right, so that's the second part of this in terms of staying on top of everything and being a good architect. And then this is all about collaboration. And this is one of the big things that I've run into while I've been both an architect and not an architect, is that, and this is also true for tech management, right? A lot of times what happens is you're a really good software developer. So guess what? We're going to promote you to be a manager. It's like, but does this person actually have any management skills? Have they been through training for management, right? So a lot of times, like when you hear, oh God, I hate my manager, he's not good and he doesn't like listen. Well, it's of course, he's a great software developer and they just threw him into, because the promotion track used to be, you go from being, a junior developer to mid developer to senior to principal to whatever. And then the next step is management. Does that make sense? Of course it doesn't, right? So, and similar thing kind of happens for architects, is that they say, oh, you're a really good principal software developer. You write great code and you write code very quickly, it's clean and blah, blah, blah. Why don't you become an architect, right? But those are two different things. So, you have to, a lot of people think that the path forward is always to be an architect. But fortunately, in a lot of places have realized that you don't necessarily want folks to do this, right? You want folks to be able to, people who are really good at the programming and coding side, to stay there if they feel like that's what they want to do, and have a promotional path from like principal to like distinguished engineer or something, where they can still be hands-on coding and maybe dip their toe in the architecture side a little bit. So again, every place is different, okay? All right, so let's dive into some of the topics around this. Do a quick time check. And so let's talk about architecture and code. These are the three major areas we're going to cover for the rest of this. architecture and code, processes and tools. Okay, and before I dive into this, how many people are not Java developers in this room? And okay, what do you code in? Python. And lots of what? Okay, gotcha. Yeah. Okay, that's fine. I think anybody in this room, even if you're not a Java dev, will get something out of this. Maybe in the tools part, might be a few things that are different. Okay, so the first question is, how do software architecture patterns help produce better software and code? Right. So you probably have heard of a whole bunch of different patterns, both at the low level, mid level, and high level. And this is the slide that I use to remind myself how we think about software architecture and code. Okay, so I put this on 3 different axes. So software architecture helps provide a team or multiple teams a solid foundation for building code lockstep together. So that includes you have all the developers on the same page, you have some kind of knowledge base internally for that product, which is proprietary for whatever project or whatever you're working on, okay? Software architect also can help manage complexity and make maintenance easier. The way this specifically helps is you have less bugs and you have higher levels of reuse among your code base. So reuse is a little bit of a difficult thing to nail down, right? Because for a long time, especially in the Java world, we thought of what as the way that we reuse code, right? What do we do to reuse code, right? What would you do at your company or used to do or do today to reuse code between teams or even on the same team? Make a library, right? And if we think one level below a library, the thing that you would do is that's kind of object-oriented programming, right? You basically build classes, you try to have classes which are generic, and those classes can be used in multiple ways, and yes, you package them into a library, absolutely true, right? And nowadays, again, this is the whole kind of how you think about things and thinking of modern coding practices or development practices in general is nowadays, yes, we still as Java devs or whatever developer, we still reuse libraries and build stuff out, but things have moved to a point where we reuse services, microservices specifically, rather than actually reusing code. So instead of pulling a library into your project, what you do is you say, I'm going to use this authentication service, and it's no longer ldap.jar, right? It's a joke, obviously. Is anyone still using LDAP to do authentication? Okay, good. I remember having to do that a long time ago. It was not fun. But yes, I would pull ldap.jar into my project, and I would build something to, basically use that to build some kind of authentication authorization mechanism. It was very painful. And now what we do is we just call an authentication or authorization service, whether it's something you built internally, or maybe you built it on something like Okta or Auth0 or something like that, right? So the last thing is, and this is probably the most important in terms of software architecture and code, as an architect, this is where you can have the biggest impact, I think. You're able to help teams scale. Right? So if you remember earlier, I said there's this whole, there's this myth of the 10x developer. And actually, I don't think it's a real myth in a lot of ways, right? This is not a popular opinion. This isn't being recorded, right? Just joking. Is that there are actually people that you can have on your team who are that 10x developer, right? I used to work with some of these people. These people they were just born genius coders, right? But the problem is that's the only thing they were good at. They weren't good at doing anything else. If you gave them business requirements, they would come up with their own interpretation of these requirements and implement them, which then you go back to the business owner, they're like, yeah, this is not what I wanted, right? But they're great coders. So one of the things that architects can do in terms of scaling teams and helping people who are really good coders to be major contributors and be that 10x developer is basically mentoring them and saying, look, this is not enough that you're a great coder. This is the architecture you use. You can't go off and use any old thing that you want. You can't pull in any library that's out there. And you have to read the requirements. And this is how we build things around here. So some of it is actually mentorship, right? So anyways, getting to the specific things, a good software architect enables larger teams with less friction and less overhead. And they also help a project, again, and this goes into the system design part of it, deploy faster and more often, right? So I have a quick question in here for the room. How many people deploy or can deploy once a day? Okay. So John, how often do you guys deploy over here, just out of curiosity? How about answering both for us? Okay. How often do you do like the total thing?
We actually do like on the order of like close to 1,000 deploys a week.
1,000 deploys a week. Wow, that's a lot.
Wow.
That's insane. Yeah, I mean, it's not insane. Sorry, that's the wrong word. That's very much on the leading edge, I think, or bleeding edge, if you want to call it. So how many people deploy like once a week? Okay, on average. Okay, that's reasonable. How many people deploy once a year? Okay, how about somewhere in between, like every 6 months or something like that? Anybody? Okay. All right. So when I was at AT&T and Architect, we deployed every 4 months. That was our deployment cycle, right? And a lot of it was because of the architecture of the system and just the size of the team. There were literally on every release, there were about 10 to 12 teams with about 10 people in them. So you're talking about over 100 developers working in kind of a unified monolith. Part of the problem was it was a monolith. So there had to be a lot of coordination between all the teams, make sure all the, not API calls, but all the low-level system calls, everything was decoupled using messaging. So it wasn't quite APIs, but it was low-level JMS messaging. That was, and then of course, you change a message over here, somebody else who receives that message has to adjust for the shape and the contents of the message and things like that. So anyways, this is also a great slide. So again, whether you're a software architect or not, I think I find this slide really useful in terms of thinking about things, both from a systems, people, and complexity code management perspective. And we're going to spend more time with code management and complexity in just a minute. Okay. So let's talk about these things very quickly. I've already spoken over all these, but we'll just cover them, some of the things I may have missed here, right? So a solid foundation for code, software architect, ensures that the devs are working on the same tech stack. You don't have people going off and doing things on their own. Yes, you may sanction either yourself working with somebody, or when your developer is going off and doing some exploratory work, but that has to be contained, right? You can't, the problem with like fancy new stuff, what's the term that they use? RDD. Has anyone heard of this kind of development? It's called resume-driven development, right? So this is something that you need to avoid, right? It's fun, and you may have someone very enthusiastic who read something on Reddit about this amazing framework or library, but as a software architect, it's your job to encourage that kind of enthusiasm without doing a thorough vetting of something and bringing it into your system. And again, if we use an example that's apropos for right now today, there's a lot of people are interested in artificial intelligence, right? And there are 3 major frameworks in the Java space that you can write AI. This is on the inference side, not on the model training side, that you can basically integrate artificial intelligence or semantic type search into your app. And that's LangChain for J, LangGraph, and Spring AI. Are there any others that I missed, Mary? Those are the 3 big ones, right?
Spring and semantic kernel.
There's also semantic kernel. Semantic kernel is not as popular as those 3. Is that right?
That's right. You're right.
So anyways, so if we think of that example, right, you have someone who's like, yeah, I'm really interested in this AI stuff. And you're like, okay, you talk to their manager. It's like, okay, let's do some exploratory stuff about it. But now, as an architect, you have a very important decision to make, because as everyone knows, once you build a framework or pick a framework like this and you start building stuff on it, the difficulty in moving to a new framework is basically like, in the early stages of the project, it can be easy. You say, okay, we tried this framework for using, let's say, and again, this may not be true, but you tried LangChain for J, you're like, actually, this is not great. It doesn't fit our needs or whatever. Let's use LangGraph instead. Now you spent all this time, God knows, maybe at this point, hopefully it's a small amount of engineering time that you spent building out like a prototype with it. So at this point in time, it's easy just to throw that away and basically start over with LangGraph or Spring AI or whatever, right? But what about if you're 6 months or a year into a project and you discover that actually this selection of LangChain for J was not the best thing for this project? Now what's the cost and the risk of pulling that out and putting something else in, okay? So anyway, my point is that keeping people on the same tech stack is important. Being able to do exploratory work so that you're advancing your business or whatever your business folks need is also very important. right? How do you balance those things? Right, then of course, as an architect, a knowledge of the overall system design. I spent a lot of time doing this when I was an architect, which was explaining to people on the on teams that I used to work with routinely and teams that I didn't work with that often. This is what the system design looks. We use JMS. We deploy into these kinds of app servers. This is what our kind of low-level service level requirements are and things like that. Okay, and then of course there are loads of books and things on proven patterns, both at a low and high level. So like, for example, one of the presentations that I've been giving for a while is on enterprise cloud patterns. How do what are some of the high-level cloud patterns? Like, you've probably heard of some of these, like CQRS, for example, right? When is CQRS a good thing to use versus just using a messaging platform? Should you use event streaming? Everyone's using Kafka. Let's get on that Kafka train, right? But is it a really good idea? Should you just stick with like ActiveMQ or RabbitMQ? Is that better use case than event streaming, right? I actually came up with this recently when I was talking to an Azul customer. They were using Kafka, and one of the things that Prime does is that it makes Kafka, like, you basically replace OpenJDK with our high performance VM, and you get basically 30–40% better throughput, right? And part of the reason we were speaking to them was because a lot of people don't know this about Kafka, is say you set up a Kafka broker-like cluster, and you have 10 Kafka brokers, and the way Kafka works is you federate messages into those 10 Kafka brokers, right? Whatever the numbers, it could be 10, 5, or 100, or 1,000. Now, let's say that you're hitting the limits in terms of how performant those Kafka brokers are. How do you go from 10 brokers to 15 or 20? Basically, let's say in the next year, the business says we're projecting a doubling in terms of usage of this specific feature, which uses Kafka underneath the hood. So as an architect, you're thinking, okay, now I need to go probably from 10 to 20 because we're going to double the number of messages which are going through this event streaming Kafka platform. What's the problem with that? Anyone use Kafka in here? Okay, so what's the problem with deciding one day that you're going to go from 10 brokers to 20? You must know this answer, John, right? Okay, it doesn't matter. Who else raised their hand over here? Okay, that's fine. I'll reveal the punchline here. The problem is that once you set up a Kafka broker and you send the messages for this specific subset of the overall messages here, you can't just say, oh, let's add another broker that will get the same messages. What you have to do is you have to take that broker and you have to split it into two, and then you have to take all the messages that were in the original broker and basically stream them, cut them in half and stream them to those two new brokers. So when are you going to do that? Right? You may have like 1 million or 1 billion messages in that one node in that Kafka broker. Now you want to, because of capacity reasons, you need to split that into two. So now you have to spend a whole weekend streaming, or maybe longer, streaming all those messages into two brokers, and then multiply that by 10, so because you're going from 10 to 20. Right? So again, as an architect, these are some of the things that you have to think about, right? You can't just jump in and say, yes, I want to do some RDD, some resume-driven development, get some event streaming under my belt. So let's use some Kafka. But then, on the flip side is that, okay, if we say let's do capacity planning for the next 3 years for this Kafka or this project that uses Kafka, should I just start with 20 or 100 nodes? The answer is obviously no, because that stuff costs money, right? You can't just go and spin up a whole bunch of brokers and run them, because otherwise you're just throwing money down the toilet, right? So you have to be responsible. Anyways, you get the idea around that, okay? So in terms of managing complexity, I actually spend a lot of time doing this. And again, your mileage may vary depending on your organization, right? A good architect helps lead to lower bugs in code, right? We'll talk more in detail about this in just a second, right? But we want low-level code reuse. We want the capability of low-level code reuse, but we also want high-level reuse of service. And this, again, will depend on how your system actually looks, right? A lot of people who are using microservices will angle towards the high-level reuse between services. Basically, you reuse services rather than code. But if you're running in more of a monolith style, or if you're swinging back from microservices to modular monoliths for performance reasons, then we have to think about low-level code reuse using libraries, reusing objects, reusing classes, and things like that. Okay, so we're going to dig into these in a little bit more detail in just a second. Okay, and then the last thing we talked about was scaling teams, or in the graph was scaling teams. Better code quality means faster releases. Better code quality means more people can work on the code at the same time, because you have less bugs, number one, and number two, the code is understandable, right? So at today's Duke Turns 30 virtual event, one of the speakers, I know Venkat was a speaker there, and his talk was great. But the one that I think that you should really watch is that probably worth your time the most is there's someone that Mary and I know, and her name is Marit. She works at JetBrains. She gave a great presentation on reading code, okay? Because everyone loves writing code. How many people love reading other people's code?
That's true.
Right? Nobody.
Yeah.
Don't raise your hand because I know you're lying, okay? Right? Nobody likes to read other people's code. Hell, what's that? Outlier, yeah, you're an outlier. There you go. You're the TEDx developer. I'm joking. I'm joking. To be honest with you, I don't even like reading my code from 6 months ago. Right? It's like, who wrote this polygon? Oh, it was me. Right? So you get the idea. Right? So you should go watch that session that she did at the Duke Turns 30 thing. It's only about 30 minutes long, but it's really nice because she talks about like what are some strategies for reading code. And as an architect, remember earlier we talked about as an architect you could do this much coding or you could do zero coding, right? So you typically will fall somewhere in between. But the one thing you definitely do as an architect is you're going to read a lot of damn code. So being able to read a large amount of code and upload it into your brain and structure it in your brain to understand it is probably one of the most important things you can do. Right? And there are ways to do that. She gives some tips on like, apparently there's actually like clubs, or at least in the Netherlands where she lives, there was a club for people who would get together and read code and come up with strategies for reading code, which is amazing, right? But one of the nice things today is we have lots of great tools. Like, if you're using JetBrains IDEA or if you're using Visual Code is not bad at this, but JetBrains is better. There's a really great way to like look at navigated code and stuff like that. I don't think AI does this really well, especially, right? AI is able to look at code right now. There are a multitude of problems, right? Are you going to take your proprietary internal code and send it up to Anthropic Cloud? Probably not, right? Because that's basically leaving your platform. And of course, one of the things that I don't want to go into a long rant about AI, I promise, okay? But one of the problems with anything like this, as you're probably aware, is that if you send code to whether it's ChatGPT or Anthropic Cloud or I'm blanking here, Mary, help me out. Or Google
Llama.
Gemini.
Yeah.
What's the other one? Or definitely not DeepSeek, right?
Llama.
But my point is that all these people, all these companies, they use what you send them for the things to train their next model. So do you really want your proprietary company's code to be used to train their model for future releases? The answer is probably no, unless you're working on an open source project, right? So anyways, there are ways around that. You could just run, there's like Quen, and there's a bunch of different coding models you can just run locally. So like if you have a newer generation MacBook, like this is an M4 MacBook, you can spec it up to, I think, 128 gigs of RAM. So if you're buying a laptop, get as much, especially if it's a MacBook, get as much RAM as you can, right? I think it goes to either 128 or 192. And the reason why I say, like, I used to work in a big corporate, actually, even the company I work for now has, the standard MacBook is, this is what you get. I had to fight with them and say, no, I need more RAM. And they're like, why? Because I want to run AI stuff locally. You don't need to do that. Yes, I do, because you don't want me sending our code up to the cloud to ChatGPT, right? So that got me 128 gigs of RAM on this, right? But my point is that you can run a lot of these models locally if you have a Mac. You can't do this on a Windows machine because these newer Macs have something called unified memory architecture, which allows you can actually go in and from the command line say, use 90% of that 128 gigs of RAM to run basically for the GPU, which is what all the AI models run on. So literally you can use 100 gigs of RAM to run AI models. So I can actually show you later if you're interested. Like I can run a 70 billion parameter model, not Gemini, which is the one I'm thinking of. It's Quen. There's several of them. But like I can run Llama 3.3, which is typically like 55 or 60 gigs in size, and then you need some headroom for context and stuff like that. And that easily fits in with that 100 gigs of RAM. So you can run all this stuff locally. It's not as good as something like ChatGPT 01 or I think the gold standard currently is Anthropic Cloud for coding, Claude. Anthropic Claude Sonnet 3.7 for coding, because they're running, basically on high-end machines, and their model is on the order of like 500 gigabytes. So it's not as good as that, but it gets you most of the way there. Anyways, that's an aside from maybe talk over beer or something. Okay, let's get into the process side of things for a little bit. Okay, just do a quick time check. Don't want to run over too much. Right, so as an architect, do you get involved in high-level code reviews? Right. So when I was an architect, I actually got involved in low-level code reviews. So I found that especially important for two reasons. Number one, I know what's happening, like in terms of low-level implementations, and are people using threads properly and things like that. But definitely at high level, getting involved with code reviews is good. There's some automation that you can do, which we'll talk about in just a second. I also got involved in setting coding guidelines. So nowadays, this isn't as hard. Most coding guidelines across the industry, especially in the Java space, because it's so mature, you can just pick something off the shelf and you're 99% of the way there, right? You can just say, I want to use this coding guideline that, whatever company X is doing, or, there's basically open source coding guidelines that you can use. And then of course, the big thing is performance test and performance reviews. Because as an architect, you may be responsible for higher level systems design. And part of higher level systems design is deployment models, and deployment models inherently also include, will this run fast enough and be able to support the low level latency we need and throughput and things like that, okay? All right. So, and this is always a fun one, because as a developer, I hated architects for this. It's like, I want to use this library. This other stuff we're using over here is crap. This other one is way better, right? So you have to be able to have standardized libraries, and no library should be used without your approval or without the architecture team's approval. I forgot to mention this actually, but like when I was at AT&T, because it's such a large company, we didn't just have an architect, i.e. me. We had a team of architects. We had like, I don't know, I think just in my division alone, we had 12 different architects. And we covered, there were 3 architects on just the part of the project I was on, which is UVerse and DSL NMS, network management system, but there are architects for other parts of the system also. So John, how many people do architecture over where you're at? Like, do you have an architect team? How big is that?
It's the main architecture manager, like, is it the domain, and then under that, we usually have like all architects who then sort of like dotted lines to like product family areas.
Right, so it sounds like you probably have about 2 to 3 dozen architects across all those things. Right. Right. So there you go. So typically as an architect, you don't work in a vacuum as an architect, especially at a larger company. A smaller company, obviously, it's different. Okay. So along with this, along with library selection, standardizing a CI and CD pipeline, of course, that makes sense. We talked about deployment practices. And then this is a big one, because nobody, including architects, like to write documentation. But having some kind of documented thing that's very light is very useful. So I used to actually spend a fair amount of time doing. I know this is a joke, or it sounds like a joke, but what I like to call sticks and boxes, right? So it's basically like drawing diagrams of, this is our deployment model, and this is what it looks like. So especially when a new developer would come on board, it's like, this is how we deploy things. So don't do something stupid like try to do your own threading. We do threading by using message consumers. Each message consumer runs in a thread. By picking a message up off a queue, that's a thread that's doing some stuff, so don't do threading, right? But having an architecture diagram to help explain that was super important, okay? All right, so let's get into the last segment of this, which is tools. And we're not gonna spend a huge amount of time for this, but does everybody in this room use Sonar? Sonar Cube? Is there anybody that doesn't use this? Okay, what do you use, John? I'm intrigued now. Okay, so you basically do what Sonar does, but you built it in-house. Okay, cool. I mean, that's perfectly reasonable. So, and who else raised their hand over here? Yeah, well, what do you use? You don't use Sonar? Yeah.
Questionable in terms of what it's saying is as important to pay attention to, and rather than deal with all that, it builds up with the individual.
No, fair enough. So the response over here is, we don't use Sonar, but we basically use the same low-level tools that Sonar does, and we stitch them together ourselves, which is perfectly reasonable. And Sonar does like have everything. And part of, if you're not using Sonar, if you're already using Sonar, you probably already know that you can't just use it straight out of the box. You have to do a whole bunch of customizations for the hundreds of rules which are in there. So as an architect, guess what? That might be your job, right? Which is perfectly fine. It's better than writing everything yourself. Sorry, you didn't hear me say that, John. But right. I know. I was just joking. Yeah. The one way to think of Sonar is that it's mostly like an aggregator of some of these low-level tools that provides a nice dashboard and provides a sane set of default rules. But you obviously have to, not obviously, but you do have to customize it because those rules are very generalized. They probably won't fit what you're trying to do. Okay, so another tool that I like using for stuff like this is something called JArchitect. It helps you visualize things. And then the last one is code inventory. So we're just going to look at these three very quickly. Okay. All right. So this is SonarQube, and this is specifically the FindBugs plugin for it. I think most of you have probably seen this, so I'm not going to talk too much about this. But this is something I actually even use today in terms of FindBugs, at least. I just use SonarQube. I have my own set of rules for the stuff that I do for putting things together. And again, it gives you a nice dashboard to see what bugs that you probably have. And one of the things that's part of this, but not specifically FindBugs, is like the code complexity analytics that come out of this. And the problem with code complexity analytics is typically that they're not like the word of God, if you will, right? You have to take them with a little grain of salt. Sometimes you just have more complex code because you're writing in-depth business rules. So you can't just like take a method and take a method and like extract it into a class. Yeah, go ahead.
And you have to understand what story they're doing. So like for complexity metrics, you expect the 80-20 rule. 20% of your code is going to be very complex, and 80% is going to be complex. If you aren't aligned with that, you have fun.
Yep, I 100% agree. And one of the things that some people focus on too much, whether it's an architect or a software developer, is a metric called cyclomatic complexity. All right, everyone's familiar with this. But again, if you're writing in-depth business rule, the 80-20 rule is actually good for that, right? It's like 80% of your code should be under a cyclomatic complexity of 1.5 or something. But it's okay if 20% is above 2.2 or 3, or sorry, 2 or 3, because these are like business rules, which are just going to be inherently complex. Now, what's that? Yeah, 17 for a parser, right? But one of the things I wanted to mention with this, and one of the reasons I bring this up and talk about this in a little bit more detail, is that these tools give you, and again, this is your role as an architect to figure these things out, right? These tools will tell you to do things like take something and extract it to a class, for example, right? Or take this block of code and put it into a method, right? And if the tool itself just looks at the code. It doesn't think about how you're deploying it. What kind of latency and performance requirements do you need, right? Because what happens if the tool says, okay, take this block of code and put it into a separate class and have its own methods and break it down, et cetera, right? Basically reduce the cyclomatic complexity by doing that. Maybe remove some code branches, i.e. if-else statements. Now the problem with doing that is that what you're doing is you're introducing low-level speed bumps in your code. Because, for example, one of the things that the JVM does, specifically the JIT, everyone's familiar with the JIT compiler, right? The JIT compiler takes your code, and as it's running it, looks at all your code, and then it optimizes that code, right? So there's a JIT compiler. What's the JIT compiler in OpenJDK called? Is it called C2? No, Hotspot. Duh, I should know this. So, for example, Azure in our high-performance VM, we have our own JIT compiler called Falcon, which is much more aggressive at inlining, making code optimizations. So one of the things that both of them actually do is something called method inlining. It'll look at a code branch, and once this code branch has been executed 1,000 times, it'll say, every time I call this method, I'm getting the exact same result. So what happens, the problem with invoking a method, which invokes a method, which invokes a method, is you're building up a call stack, right? So you put stuff on the stack. You call a method, goes on the stack. Put it on the stack, goes on the stack, goes on the stack. Every time you add something to the stack, you're using more memory, and you're doing basically an operation that's down at the CPU level, and that causes your code not necessarily to be slow, but adds overhead. So one of the things that the JIT compiler will do is it'll say, I'm going to take this method, I'm just going to inline it directly into my code, right, or into this code branch. So I'm not making a hop to call a method, putting something on the stack. There's memory consumption, overhead, and things like that. Now, the reason why I'm telling you this is because these code tools, these code quality tools will tell you to extract something to a method. But is that the best thing to do in terms of performance? It probably is a good thing to do from a code quality point of view, but if you're, especially if you're like in the, like for example, in the finance world and you do high frequency trading, or you're someone like, oh, I don't know, Grubhub, that has to send out someone's sandwich immediately, right? Performance means a lot to you. So you can't always, as a software architect, you have to realize that, yeah, it's okay that we don't like make this optimization that the tool is recommending, because this specific portion of the code is very performance sensitive and we want it to be fast. So let's not do that. Okay, so these are some things you have to think about. You can't just trust everything that these tools throw at you. Yes, go ahead. What's that? The JIT, J-I-T, just-in-time compiler. Yeah, just-in-time, JIT compiler, right. That's okay. Okay. What's that? Oh, what, the JIT compiler? Yeah, JIT compiler, yeah. Yeah. Well, I think the JIT compiler has been in the JVM since version 1.1 or something.
Yeah.
Right? Is that right?
Something. Yeah.
What's that? Oh yeah, exactly. The concept of just-in-time manufacturing. The JIT compiler is a just-in-time, so it basically happens at runtime, right? So it doesn't optimize your code until you run it. Well, I can get into a long discussion about JIT compilers and things like that. Actually, I have a question for you. Let's do a little Java JVM internals trivia for a second. Let's set an assumption. Say everyone knows what Spring Boot is, obviously, in this room, right? Okay, so you have a Spring Boot application. Let's say it's a medium-sized Spring Boot application, 20, 30,000 lines of code. So not gigantic. It's like a microservice type of thing, 10, 20,000 lines of code. Now, if you take that Spring Boot application, and let's make a couple other assumptions, using newer version of Spring, newer version of JVM, whatever, Java 11, 17, etc. Now, how long do you think it takes for the JIT compiler? It doesn't matter if it's like Azul's proprietary one or the hotspot that's in OpenJDK. How long do you think it takes for the JIT compiler to get the code for this medium-sized Spring Boot application to about 90% efficiency? Right? How long does it take? The other assumption here is that you're running this on a production system and it's under nominal or heavy load, right? Let's just say heavy load. How long do you think it takes for the JIT compiler, for the CPU graph to go up and up? The JIT compiler compiles code, optimizes it, and you reach a steady state where you get great performance or 90% of optimal performance. How long do you think it takes to hit that 90% performance mark? Remember, medium-sized code base, 10, 20, 30,000 lines of code, put it under load, you run it. How long do you think it takes to reach at least 90 to 95% efficiency for running that code? Anyone want to guess? Okay, that's not a bad guess. People usually say like 5 seconds. I'm like, okay, no. Yeah. I get one of the assumptions, it's under heavy load. That's also a very reasonable answer. Anybody else? So for something like this, again, I've made a lot of assumptions. I provided those to give you an idea of like how it works. So standard hotspot will take about 10 to 12 minutes to reach 95% code efficiency. The Falcon JIT compiler that we have in Azul Prime, our high performance VM, is a much more aggressive JIT compiler. That's why Prime is much faster JVM than OpenJDK, right? So it won't take 10 to 12 minutes. It might take 15 to 20 minutes to reach peak optimization of that code, okay? Again, 95% peak optimization. So of course you have to worry about de-optimizations and blah, 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 things like that. But that's a little bit down the rabbit hole for this presentation. So anyways, And this is, as a JVM architect or architect on a Java project, this is other things you have to think of, right? So this leads to a discussion about, okay, if you're an architect and you're responsible for the deployment and overall systems design, and you're running in Kubernetes, and someone on your Kubernetes team says, yeah, you know what, we should recycle a pod every 10 minutes, right? What's your answer is that, what would your answer be to that if you're an architect, a Java architect for the Java project? You're like, no, this is a bad idea, because what happens when you recycle that pod or node in Kubernetes and you shut down the VM? You lose all your optimizations, right? You never even reach peak optimizations necessarily if your thing is, if your code base or your microservice that you're deploying is that big, right? Now, there are ways to ameliorate that. There are some tools out there that kind of help you get to peak optimization faster. One of the things that we have at Azul is you can actually plug in something that will provide a warmed up JIT into a Java application or microservice running in a Kubernetes container that has a warmed up JIT. So instead of having a curve that looks like that while the JIT compiler is optimizing, it reaches peak optimization immediately, right? That tool is proprietary, but we also have something in our free and open source JDK that I mentioned at the top called Azul Zulu, which is 100% free. There's this technology called CRAC, and this is more of an emerging technology, or crack. I hate that word, but that's like the fast startup thing. If you haven't heard of CRAC or crack, it allows you to start any Java application like much, much faster. So for example, if the Spring Pet Clinic application starts in 4 seconds, if you crackify it, I apologize, I did not come up with the name, right? If you crackify that application, it will start up in 40 milliseconds as opposed to 4 seconds. But the important part in the conversation that we were just having is that one of the things that it does, basically the way that it works, it's like your laptop. When you finish working in the evening, you close your laptop, you come back, you open it, and it's at that exact point in time. That's what Crack does. You basically take a snapshot, and it loads from that snapshot, and part of that snapshot is the JIT metadata. So you could theoretically warm up your application, make the JIT, get to whatever level of efficiency, take a Crack image, and then start from that Crack image rather than from a non-warmed up JIT Crack image, and get that kind of really fast performance right out of the box. But that's kind of still very, very young in terms of like, will that work properly with JIT compilers and stuff like that? It works for startup at least. Okay, anyways, the next tool that I want to show really quickly is called the JArchitect. And this is against JBoss Wildfly, which is an app server, but it helps you see like all the different parts of the code. You can see there's some metrics here, code coverage by test, how many lines of code are in that specific project, and it creates like a little class diagram graph in the bottom. So this is useful for kind of looking at especially larger code bases to understand what's happening. And I'm going to go on a little bit of a rant with code coverage for a second, right? Because this is also one of the metrics that, in my opinion, naive architects focus on too much, right? Because everyone's like, oh, we got to have 80% or 90% code coverage. But does it really make sense to have that much code coverage for your project? Probably not, right? Yeah, go ahead. There you go. So that's almost exactly where I was going with, right? If you're that focused on code coverage, you're probably not spending enough time writing proper tests, or just loads of different things for that level of coverage. It's just not necessary. But again, the problem with all these tools is you look at this and you see, wow, we only have 55% code coverage. We need to make that better. That means all this code is not tested, right? But it's like, okay, do you really need to test all the getters and setters in your code? No, right? It's just unnecessary, right? It's just a waste of time to do stuff like that. Now, those getters and setters should be automatically under some kind of code coverage when you actually write a unit test that exercises the business logic around your code, right? But that can also tell you that, hey, maybe we actually don't need a lot of this code. Let's get rid of it, which goes to our next slide. And this is a proprietary tool. This is the only thing proprietary that I'm going to talk about in this entire thing. Is we have this thing called Intelligence Cloud at Azul. It's our next generation JVM tooling suite. And one of the things under that is something called code inventory. And what this does is at runtime, it looks at what code is actually being executed. Right? So there are tools out there that do static analysis, or they'll, basically they can do trace using unit tests or integration tests even. But I've been threatening to do this for a while, but the other folks on my team won't let me do this. I want to print a T-shirt that says, "I don't normally test, but when I do test, I test on production." Exactly, right? So what this tool does is it actually looks at what you're actually running on production. And so what you can extrapolate from that is what you're not running on production. So the idea is that you run our code inventory tool on a production system. It's not risky. If you're using one of our VMs, the overhead is like less than 0.1%. There's also an agent if you're using OpenJDK or Oracle JVMs or whatever. It adds a little bit of overhead, about 1% or so. And you run it for like a day or a week, and it creates all this metadata in a JSON file that you can use. This is my colleague created a nice user interface using Java effects here. So you can see what code is being run in production for your thing. And then from that, you can derive what code is not being run. And then you can say, you know what, we've been running this thing for a week in production, and like this entire segment of our code base is not actually executed. So what should you do? As a software architect, what's your next step there? You go nuke that code. All right, I'm being serious, because basically dead code or unused code is a huge sign of technical debt. And you think about, no code base is ever static. Well, this is not true in the Java world. Like, for example, at Azul, we have, unsurprisingly for the people in this room, right? You won't be surprised by this because you probably have some projects like this at your company. There are some projects which are still like on Java 7 or 8. And it's one of those things where it's like, nobody touched this. Right? Nobody touched this thing. Because if you breathe on it wrong, it's going to stop working, and we don't know how to fix it anymore, right? But anyways, the point with this is that if you're going from like Java 8 or 11, or say you're on modern Java, you're on 17, and now 25 is coming out in September, right? The next LTS release is 25 is coming out in September. You're like, okay, we need to start gearing up to make the jump from the existing LTS Java 17 to the next long-term Java version, which is 25. And maybe at the same time, we'll upgrade our Spring from 2.7 to 3.4. But if you can get rid of a huge amount of your code base before you make that transition, what you've done is you've saved a whole bunch of time and frustration and energy and all that kind of stuff. And we actually have some customers who have essentially used this to point at their production systems, and they've seen that they're using maybe 60% of their code base actually runs in production, and 40% is not even being executed. And they're in the process, unsurprisingly, and very carefully, of course, of getting rid of all that code before they migrate from 17. Sorry, their big concern right now is migrating from Spring like 2.2 or 2.3 to 3.4. So they're like, let's just get rid of all this code and then do the migration, so that we shrink the migration time by 20, 30%, i.e. number of people working on engineering resources. And then you can use those folks to actually do stuff like, I don't know, write new code or build new features. Or there's this thing called AI that everyone's in. Like, let's put those people on some AI projects, whatever it is. So, all right. So a couple other things, and these are kind of not necessarily specifically about like code quality and things like that, but the first one definitely is, right? So Mary mentioned that someone from Temporal is coming to talk about Temporal. And if you're not familiar with Temporal Restate, it's basically a framework for doing guaranteed transaction-ability across long transactions. How do we used to do that in the Java world? We used to use something called JTA, right? So for those of you who've been doing Java for a while, you remember JTA. And JTA is unfortunately very antiquated in today's world, especially in terms of deployment topologies. JTA worked okay when everything was a giant monolith and you're running everything in one JVM, right? One of the problems with JTA, though, is it would cause a lot of resource contention. Remember, I used to lead the Java performance team at AT&T. But there are tools now, thankfully, that allow you to run in heterogeneous deployment environments, so you can deploy something using either Temporal or Restate into a Kubernetes thing or a monolith or a serverless or Cloud Functions or all three at the same time, and provides you a framework for doing guaranteed transactionability across multiple things. So my preference currently is for restate. I think temporal is also good, so I'm not going to like say they're not good, but restate I think is a little bit more flexible and has some nice little like things to do things, some nice little things to make it easier to write complex kind of transaction things. So you might be wondering, what do you mean by complex transactions, right? If we take a banking example, even something as simple as someone walking up to an ATM, putting in their PIN number and doing a withdrawal usually involves probably at least 24 different steps, because obviously when you're taking money out of your bank account, the bank wants to be 100% certain that number one, you have the money, and number two, you get the money, and that transaction is officially 100% recorded somewhere, right? So there's like 24 steps in just that very simple transaction. And this is what something like restate or temporal will help you do. Again, if you're not running on an AS300 or mainframe, which a lot of the stuff is, but if you're building complex transactions of any kind, it doesn't just have to be in finance. Okay, now the performance tools is always a little bit of a sore point for most, especially Java devs, because there aren't great performance tools in our area that like you just say, okay, just run this thing, plug in this tool, and boom, we'll find out all the performance problems, right? But there are some decent performance tools. For low-level stuff, there's JProfiler. Billy is probably going to come talk about JProfiler or whatever in a few months. I think you're Billy Crandall from the Oracle Java team. He gives talks on that kind of stuff. But when I do performance profiling for our customers, I just use some simple tools. I literally just use garbage collection dumps and sometimes, GC logging specifically, not garbage collector dumps or heap dumps. I just use GC logging, and I don't try to insert profilers in there or anything like that. But I can talk to you. I have a whole presentation on performance tools for JVMs. But just some simple things like looking at the operating system, CPU utilization, taking thread dumps over time. And there's something called EasyGC, and there's another corollary tool by the EasyGC people where you can just drop in a series of thread dumps and will help identify bottlenecks in your code. So I like to use simple tools instead of like really elaborate tools. Are folks using things like the Java Flight Recorder is good. The problem with Java Flight Recorder is that it does instrumentation into the code. So it's one of those things where using the tool affects the performance of the application. It adds overhead and it does instrumentation and things like that. So by all means, JFR, if you get stuck, after you take some thread dumps and you do analysis of thread dumps over like a minute or 5 minutes, depending on the application, you can identify the problem. That's when you break out the big JFR hammer. But usually I find that just taking some thread dumps you take a thread dump like every 10 seconds for 2 minutes, and then you drop it into a tool and it'll say, this thread seems to be stuck a lot. And you can see that it's doing like this thing or these groups of things, and that helps you get to that place. So, okay, the last thing is AI tools. We talked about AI a little bit. There are some AI tools that actually produce really good unit tests, but as we mentioned before, like unit tests are not the end-all be-all. And there are, one of my problems with AI right now for doing coding stuff is that even though everyone who sells AI tools says, yes, this is great, you should use it, in my opinion, we're still so early in this cycle right now, right? Like every week there's a new AI model. It feels like every week there's a new AI model coming out that's better than the last one, right? And there are these tools coming out that help you with code assistance, and the code assistants that currently exist, like GitHub Copilot, are really good. But just last week, for example, the JetBrains people released something. It starts with the J. It's like Junie. That's it. Thank you. I was going to say Janice, but you're right. It's called Junie. Have you used Junie? Is it any good? Yeah. Has anyone tried the new JetBrains AI assistant tool? It's called Junie. Yeah, I haven't had a chance to look at it. It literally came out last week. Anyways, my point is that I think these AI tools are pretty good right now, but the space is moving so fast that a tool that you may be using today that works reasonably well will probably be superseded by another tool, maybe from the same company or a new version of that tool that's even better, right? So there's a lot of talk about like just generating apps. If you go to YouTube, YouTube is the worst place to learn about this stuff, unfortunately.
That's right.
Because, if you think about it, a YouTuber who's putting out like videos like this, that person's goal is to get as many views as they can so that they can make money or sell some kind of sub-product or whatever, right? This is not 100% true, of course, but generally speaking, and the YouTube algorithm generally tends to pump up those, which, those people who are producing lots of videos and things like that. So a much more sane place to kind of get this information is just honestly just by reading stuff in Reddit, right? Who would have thought that Reddit would have been the source of all truth today? It's like so true. But anyways, if you look at Reddit or look at like the Java channel, there frequently people are asking, oh, what tool should I use? And then you'll get the state of the art today, right? And so, or for 4 months ago, whatever that Reddit post was. But me personally, I like using Copilot to do AI stuff. Again, this has not much to do with software architecture, but there's this other tool that I really like called C-Line or Klein. It's a plugin for Visual Studio Code. It doesn't work in IntelliJ IDEA yet, but I think Juni supports the same kind of thing where you can look at a code base and you put it into architect mode, right? So they have two modes, architect and action mode, or Klein calls it plan and action mode. And with the plan or architect mode, especially if you're using like a commercial non-local tool like Claude, Sonnet 3.5 or 3.7, it will look at like a fairly large amount of your code and help provide some tips on how to make some improvements to it, and without making any changes. So you can literally go into there using C-Line or Juni, I believe, and just say, look at this package in this code base and tell me how I can improve the threading that's going on in these specific set of classes or something like that. It will actually reach into the AI, send it your code. You can run some of this stuff locally, again, as I said, if you have a high performance or high RAM Mac and run like Llama 3.2 or something. And it will look at it and say, I would suggest that you make these improvements, right? It'll say, hey, maybe split these into different classes and use virtual threads or something like that. So, okay. So we're almost at time now, so I will, we're actually past time. So that was the last slide. Do we have some time for questions? Where's Mary? Oh, there she is.
Questions, yeah.
Yeah, we'll take a few questions. Yeah. So you guys have some questions, some comments. Hopefully some of this resonated with you around this stuff.
Question?
Yeah, go ahead.
The potential bias. In data analysis, data science, we take a way a lot in this bias because data flows derived from estimate and deviations for bias. So what's your potential bias? It's especially Java development.
Yeah. Right. So the question is, what are some biases that I have as a Java developer? Is that right? From
Java development.
So like biases as an architect or biases using the AI tools? Or so one of the slides I mentioned potential bias, right? That mostly has to do with bias in terms of your own experience as an architect, right? So I'm a old school Java guy. So I used to think in terms of monoliths, and I used to think in terms of like that's the best deployment strategy. Well, again apparently it is again too with modular monoliths, but it's the biases based on your experience, and a lot of it has to do with also not being up to date on everything. So you may have somebody like that's on one of your teams that you're a software architect for, and they may say, hey, you know what, instead of using JTA, we should use restate or temporal to do these long transactions. But in my mind, I've been using JTA for years. It works, maybe a little slow, it has some issues, but as you know, as a software developer, and especially as a software architect, the golden rule of software architecture is that nothing is free, everything is a series of trade-offs. I didn't come up with that. There's my friend Neil Ford, who's written a whole bunch of books on software architecture. That's like his golden rule, right? Again, the rule is, in software architecture, it just like in life, nothing is free. Everything is a series of trade-offs. right? So when I think of biases that I may have, and I think about like, oh, when I first look at something like temporal, I remember when I first looked at temporal, I was like, wow, this looks so complex to me. I'm just going to stick with JTA because I know how JTA works. It works within the ecosystem that I'm running in, et cetera, et cetera. But it turns out that looking at and considering something like restate or temporal is actually a good solution long term because I'm now deploying into a heterogeneous environment. So that's what I mean by bias, right? It's the experience that I have, I carry it with me, and I have to make sure I keep an open mind as an architect that if someone comes to me, even if it's a little bit of a crazy idea, to at least give it some airtime and to think about it and to try to be open-minded. Okay, that's all that's basically where the bias part comes in. So, okay. Yeah, yeah, of course. Every software architect or developer is a human. So we all have our personal preferences and the ways that we look at things, right? Right. Yes.
New team. This team is very mature. A lot of senior guys.
Yeah.
Their code base is high quality. They're
Yeah.
delivering on. This is your new role. What becomes your responsibility in this team? They already have a lot of things you talked about.
So the question is you are a new software architect on an existing team that's working very well together, and they're producing high quality code and stuff like that. So obviously,
Very little.
right, you don't have any business context of this new team. Obviously, the first thing you do is you make your presence felt, and you come up with a whole new set of guidelines for everything, right? I'm joking, of course, but I've had to do this a couple of times where I got reassigned to like slightly different team and stuff like that. That when someone left and things like that. But this is where like the soft skills really come in with architects, right? It's first thing you have to do is you have to build trust and rapport with the folks who are there, right? Because now all of a sudden you're not their manager, but you're essentially making decisions or helping them make decisions, do things. So that's like the first big thing. The second part is just thinking about how much of this system do you know and learning everything, and then there's probably a reason why they made you a software architect on this. Maybe this team of developers is like really good, has built this amazing system, but it's a monolith. And now you need to refactor that to a microservice. So the third arm of that, in my opinion, is now you go into that whole education phase. Okay, this is a great monolith, but the problem is we can only deploy once a month because it's 80,000, 100,000 lines of code, and it's complex, and all the code is weaved together. It's well done, it's high quality, it's got loose coupling but high cohesion. So everything has been done in a very nice way from a code perspective, but we need to make it a microservice so that we could have more flexibility in deployment and whatever availability. So those are kind of the three initial things that I would think about, right? It's learning the system, building trust, and then educating them for where you're taking them, right? It's that vision thing. It's like, hey, the company is moving in this direction. We all need to move in this direction too. So, okay, it's a good question. Okay. I think we'll take one more question. It'll probably be time. Yes.
Yeah.
Yeah.
The transition from architect role which has picked the route, then they're transitioning to a complete management role where they're not looking at code at all. Do you think should like for 6 months
Yeah, that's a good question. Unfortunately, it's not something that there's a generic kind of response for. And I think a lot of it depends on the person too, right? One of the things I said at the top is that what you do as an architect, how much coding you do as an architect, is heavily dependent on you, your company, and what your role is, right? So there's like three things that come together for that. I know some architects. I've worked with some architects who did zero coding, but what they did is they specialized on system design, right? So they would basically focus on the overall system, right? They didn't get involved in the coding. That's something I would do as an architect, working alongside this architect. But that other architect would think about things which were kind of a little bit more expansive than just how are we deploying our application. They would think about something like, for example, very specific example would be, well, this part of the system has to communicate with this piece of equipment that's sitting on the curb down on LaSalle and Wacker, right? What's the latency for when we make a call in our software system to go reconfigure that, that network management switch that's controlling a DSL or UVerse endpoint, right? So they would consider like this latency is happening, and if it doesn't work immediately, or if there's something wrong with that, do we need to fire off a different workflow that goes and sends a truck, a technician to go replace that hardware because it needs to be updated or whatever, right? So they would worry more about those kinds of like kind of almost business things, or like larger network types of things, or larger system design things, right? So there are people who worry just about that kind of stuff and not so much about the code. So again, it's a lot of it is dependent on like what your company does, what you do, what your teams do, and stuff like that. All right. All right. All right, Mary?
Yeah, good.
Okay.
Yeah, thank you. Okay, so thank you. And we have our raffle. Thank you. Thank you, Pratik. Right, yeah. And I can do the raffle. Oh, I think we only have 5 people enter into
the raffle. Doing a raffle. Don't leave yet, right?
Yeah, don't leave. That's right. Yeah, do not leave yet. If you're up for the raffle, let me get there. Yeah. Sure. Okay. Let me actually, let me see if I could. Share. Oh, let me share that thing. Let me see. Can you see that? Yeah. You can see it, right? Or oh, it's okay. Yeah, that's fine. So actually, we only have.
Here you go. Let me look at
yeah, my microphone. I almost forgot. Yeah, thank you. Okay, thank you. Hello. Excuse me. Who else? Okay, let me read the names. There are 5 people: Abhishek, Pujit, John Coyne, but I think John left, and Mikhail, and Alexandra. Yeah, you. Okay, so I guess we only have 4 people. But we have 2 chances. So just want to make sure, are you all local, right? Abhishek, Alexandra, Pujit, and well, John isn't here, and then I think Mikhail, you are in Germany or something. But so sorry. Oh, one more name. Okay, sure. Let me enter you. Actually, do you mind entering our raffle? But we'll enter your name first. We'll just yeah. Well, if you win, let's put it like that. Yeah. DERA. DAR. Oh, Dara. Okay, Dara. Okay. All right. So make sure your names are on. Okay. Ready? Okay. Let me turn back on the sound. Sorry. Oh, I guess John, but John left already, so he doesn't qualify. We'll do again. This one for Jet.
Must be present to wait.
That's right. Who did? Yeah, you're there. Okay, yeah, okay. I got your. I'll send you the license certificate. Okay, and then now, this one is for the Great Lakes Symposium. So you will get a free admission. Okay. Yeah, something like that. Alexandra, oh, great. I know you will go, so I will connect you with Jay, and then you get the free ticket. Okay, great. And thank you so much again to everyone who has joined us tonight. And I hope you can join us again next week and also for future. Thank you. Awesome. Okay. This will be an Itasca. Itasca, it's, you know what, 355. If